Okay, this is page 52 of our 6A workbook. This is level 1 problems. We are going to do question 3 and 4 together. These are problems got to do with fraction divide by fraction. Now, by now you will have heard how we have used the strategy of GT and KCF to solve fractions related problems. And let's see if they still work here. Okay, with my raised steps as usual. So Mr. Lee here conducted an experiment in 6 hours. During the experiment, he had to check the temperature of the water every 1/6 hour. How many times did he have to check the temperature of the water? So the question says how many times he has to check. So the answer will be in times, the number of times he has to check. So we are going to look at GET, and using this multiplication and division concept, it would probably still work very much how to solve questions. So the science experiment is conducted in this amount of time, the duration, this entire duration, and for every that means each, for every 1/6 an hour you have to check. So the total amount of duration that the science experiment, that's the one, then this each. So how many times refers to the group, the number of times he has to check. So you are looking for groups, that means total divided by each. You have the number of times he has to check will be the total, which is 5/6 an hour. Okay, I'll just remove the units here. Divide by the 1/6. So in other words, in this amount of time here, how many times can I take out this amount? So the altogether is 5/6 an hour, 5/6 hour. And then how many times can I cut 1/6 hour out? Alright, if you were to do the keep change flip here, so I keep the first fraction, change, divide 2 times, flip it over, you get 5. Now, if you look at the model that I just drawn here, this is the whole is 5/6. So how many 1/6 can you find out of this 5/6? Okay, then you realize it's pretty obvious. It's a simple fraction here. So you can see there are, out of this entire 5/6, there are 1, 2, 3, 4, 5 1/6 in it. So that's how the differentiation works. And the keep change flip works. In the model drawing, because these are two pre-friendly fractions, it's easier to find. So he has to check 5 times. Okay, so that's the first one for question 3. In the same way, you should be able to deal with question 4. Now question 4, so the question is, if the key tip to help you to get to the answer is to ask you which of the identities are given in the question, which identity you're supposed to find. Is it the total, the group, or the each? And then that will decide to help you decide whether you're using times or divide. And then you are using the operation involved. So here the rectangle, the whole rectangle, figure A, has the area of 3/4 square meter. The whole rectangle. Figure B has an area of 3/16 square meters. It's cut out from figure A. Find the greatest number of such shapes as figure B that can be cut out from figure A. it looks complicated because there's a diagram and then there's a portion that you cut out, and you might feel like, okay, I need to want to draw it and cut it. But you think about it, can I apply the same concept using the total and then the each? So one piece here, one piece here, each is 316 square meters. The total is 3/4 square meters. So you're looking at how many shapes. So that's the number of shapes. That's the group. So you need to look for groups. So you have this, you have this, you are looking for groups, so you use divide. So the total divide by each, you have total is 3/4 square meters. Divide by each piece is 316 square meters. And I can keep change flip. So I keep 3/4, change the operation, flip, and I can simplify easily. We have 4 pieces. So four such shapes can be cut from figure A. Now, if you were to use the modern method, it gives you the same answer, such that you saw this is the whole thing. This whole thing is 3/4. Is in each piece in quarters. So this is 3/4. The whole thing is 3/4 square meter. If each piece, one piece that I cut off here, each piece has a 316 square meter. So you are asking yourself, how many pieces of 316 can I find within this whole 3/4? Now, looking at the denominator here, you will realize that, okay, so I might actually have, I can see the relation by chopping it up into smaller pieces, so it's greater number of the denominator of the quarter. So originally it's 3/4 here. 1/4. It's supposed to be 3/4 of meter. 1, 2, 3 units. And I get that I have to further divide this into smaller parts. So